Hey everyone, my name is Ronak back with another video, and this is the new video that we are going to cover. And in this video we are going to learn the statistical inference and interval estimation. Okay, so yeah, now we are going a notch up, like I said in the last video itself. So this is one of the videos in the stats for CS applications playlist. Okay, you can just go into my channel and you can check in the playlist section and you will have the entire playlist. Okay, if you are missing on some or the other videos. Okay, yeah, so let's get started. So what is basically statistical inference? So let us start with the statistical inference itself. So this is pretty much going to be theoretical, and interval estimation I might show you one or the other example. Okay, I would say the definition of the word inference itself is that a conclusion reached on the basis of the evidence and reasoning. This is the most, I would say, meaning of the word inference. Okay, so you basically have something with you, okay, and you actually try to reach the evidence. Okay, you want to get onto the verdict. Okay, that is the human nature. Whenever I offer you something, the susceptibility of your mind is supposed to give you a conclusion. Okay, so you basically scrutinize a particular thing whenever I offer you. Okay, let's say I am offering you a graphic card. So what you are going to do is you are going to basically come to a verdict that whether it is worth investing in that graphic card or not. Okay, so you are going to go on to the sum of the parameters of that graphic card. Okay, and how those parameters are basically going to meet up to your needs. Okay, and basically that procedure in which you get the verdict is basically done by using the evidence and reasoning. Okay, you basically reason everything. Okay, I'll tell you that a particular Nvidia card has so and so number of CUDA cores, then you are going to ask why. So that is reasoning. Okay, then I can tell you it depends upon the clock speed and everything, and then you can also move on to the evidence. Okay, I can give you some specs of the graphic card, that it has let's say 3 fans or a particular amount of RAM and everything. Okay, so you gather the evidence itself, you reason it, and you scrutinize the entire thing and come to a conclusion which is finally going to give you a verdict. Okay, a proper verdict that whether you have to invest in the particular thing or not. Okay, so that is inference. So in statistical inference, now let us move on to the statistical inference. Drawing or deriving an inference from the probabilistic sample derived from the population parameters is known as statistical inference. Like I said, if you have a lot of data, okay, let's say I have a set of graphic cards and I want to choose a particular graphic card. Okay, so based on that probabilistic sample, that which is going to meet my needs. Okay, let's say I want to play a high-end 4K game. Okay, definitely you are going to go much higher into the series of the graphic card. Okay, where you are going to require a lot of virtual RAM, or you might look at the construction, the fabrication of everything, the card, and how much it is going to bear the load and everything. Okay, so those are your parameters from your population. Okay, your population states that those are the parameters, and you have set of graphic cards. Okay, you can have 1,000 graphic cards and you want to select one particular graphic card. So that is where you derive an inference. So this is statistical inference, how you are going to study that entire population data. So the procedures that work on the statistical inference are estimation and significance testing. Okay, so these two are the only, I would say, procedures that are mostly considered with the inferential statistics, and these are extremely important. So hypothesis testing comes under these two categories. Okay, we are going to look at that, don't worry at the moment. So now the first statistical inference test that I'm going to cover is the estimation. Okay, so let us start with the interval estimation. Obviously there are a lot of estimation parameters, I would say, not parameters not the actual word, I would say a lot of methods. Okay, there are a lot of methods. Okay, so there is point estimation and everything, but we are just going to cover with the interval estimation, which is the most prominent, I would say, and it is closely related with the hypothesis testing itself. Help you derive the confidence interval itself. Okay, so this is a prerequisite for confidence interval construction. Okay, so this video is extremely important. If you want to go to the earlier videos, the latter videos, please refer this one. Okay, otherwise you are not going to get anything. So after deriving sample from any population distribution, we have to check the statistical estimation. So what is estimation? Okay, so let's say I have a test, I study for a particular amount of hours. So whenever you give that particular test or examination, whilst returning home, you have an estimation in your mind that your particular marks are going to fall within a particular frame. Okay, so let's say there is percentage. Okay, I want to, or let's say CGPA. Okay, my GPA. Okay, I am going to look for my GPA, and in that GPA what I would say is, let's say I have written paper fairly well. Okay, and I am expected to get around 8 GPA out of 10. So what you tell to others that yes, I believe that my estimated GPA is going to be 7.5 to 8.5. So that is the frame. Okay, that frame you estimate in which your predicted value is going to fall. Okay, so that is interval estimation. So this can be checked using the interval estimation, like I said, in a procedural manner using the confidence intervals. So confidence interval construction we are going to look in the next video, because it is going to be the lengthy one. Okay, this is just the basic one. So for now, just have a look at the confidence interval itself. What is the confidence interval? It is an interval with some probability attached to it. So it is derived from some unknown characteristics of the population data. Okay, so your population data not all the time is going to give you a simple result. Okay, some things might be pretty much hidden in it. Okay, they might be pretty much intrinsic, I would say, and you have to dig those. Okay, so that is the work of the statistician. Okay, the particular person, he or she is going to take the data, and then he or she is going to study the data till the period where the particular person is satisfied with the anomalies in the data. Okay, so that is also one way to say it. So confidence interval basically is basically given like this. Okay, so there is a lower limit and there is a upper limit. Like I said, if I have studied for 8 GPA, I would say that my GPA can lie between 7.5 to 8.5. Okay, so my lower limit is 7.5, my upper limit is 8.5. So that itself indicates that I won't be crossing 8.5 CGPA, and apart from that, I can also define that I am not going to fall less than 7.5 GPA, and then you are going to perform the confidence. Okay, and mu is basically the value that you have. Okay, so if I am estimating let's say 8 GPA, my lower limit is 7.5, upper is 8.5. okay, that manner. So what is lower limit? So lower limit is basically x bar minus margin of error. Okay, so these two terms I'll show you in the next video itself. Okay, don't worry at the moment, but basically the margin of error is let us have a look at it in the example itself. Okay, I'll try to explain it as much as I can. And upper limit is given by x bar plus margin of error. Okay, let us hop onto an example for better intuition. Actually, I was not covering a lot of examples, but I think I should be covering a lot of examples. Okay, because they are going to give you a better intuition of the things that are happening around. Definitely this is not in confidence interval construction. Okay, the exact construction I'll be covering in the next video. You don't have to worry about it at the moment. Okay, but this one confidence interval example for intuition. Okay, so this is just the confidence interval example that I'll be covering in an accelerated manner, and the construction part we will leave it for the next video. Prognostication of the payment share for freelancers in a networking project based on the given test cases. Okay, so this is a company where there are a lot of freelancers, and these freelancers are working on a networking project. Okay, and there are a set of test cases given by the company that need to be satisfied by those freelancers, and then a particular amount has been allocated to those freelancers, and then that share will be distributed very well into amongst them. Okay, based on the number of the test cases they solve. Okay, so that is the problem, and what I want to do is I want a prognostication of the payment share that a particular person is approximately going to get based on the test cases. Okay, so actually confidence interval is going to give me a frame within which my I would say the income share is going to lie. Okay, so let's say I have $100,000 or 100,000 rupees, let's say, allotted for the people. The particular percent is going to be the share of that particular freelancer. Okay, so assuming the engineers are named A and B. Okay, so we have two engineers which are basically the freelancers in the company. We want to predict the payment for A. So assuming that there are two engineers, I want the prognostication of the payment share that I'll be giving for the A. So let us assume that there are 500 cases given in total. Engineers are supposed to fulfill all of those. Okay, there is no second thought about that. 300 cases will be handled by A and 200 by B. That is how they are distributed. Okay, so let's say the A is more experienced, okay, in handling the test cases, so 300 have been allotted to him and B have been allotted 200. now solving the problem. Okay, so this was actually the statement, and now we have to find the confidence interval. Basic derivation is 60% of the test cases will be handled by A, because I want to prognosticate the payment share for A, not for B, and since there are 500 cases and 300 are allotted to A, 60% of the test cases are allotted to A. Okay, so basically I have converted it into percentage. So confidence interval we are estimating is 95% for A. So basically confidence interval, like I said, so if I want to let's say prognosticate it for 95%, so the 95% accuracy is going to be there. Okay, so that statement basically states this. So 95%, I would say, of the time my prognostication of the let's say share of the freelancer is going to be true. So that is how we can just get an intuition about it. Next is, so confidence interval construction gives us 55.7% to 64.3%. So basically 60% of the test cases the person will be solving, and let's say $100,000 have been allocated to that particular person. So definitely 55.7 indicates that $55,700 to $64,300 have been are basically going to be the payment share for A. Okay, so that is how we actually do it. Obviously there are a lot of parameters that let us assume that 100 of the test cases are not being solved and everything. We just don't want to have a look at that right now at the moment. Okay, but yeah, this is how it works. And so the margin of error is plus minus 4.3. So what is margin of error? See, I have 60% of the test cases with me. If you subtract 4.3 from 60%, I'll get my lower limit, which is 55.7, and if I add 4.3 to my 60% of the test cases that I have, I get 64.3%. so that is basically the margin of error. Okay, the margin of error is static for the negative and positive. Okay, so you also have to subtract to get the lower limit, you have to add to get the positive limit. Okay, so that is how it works, and the graph looks something like this. Okay, so just forget about the minus 1.96 and plus 1.96. okay, we don't want to look at it, but this is how the 95% confidence level is going to look. Okay, so 55.7% lies on the left side, that is my lower limit, and 64.3%. okay, so basically this statement states that my test case handling done by the A freelancer for the XYZ company is not going to, like, the payment share of that person is not going to fall below 55.7. Yeah, so this is it for this tutorial. In the next tutorial I'll be covering the confidence interval construction, which is also going to be extremely important, and I would say that this is the prerequisite for it, so that you will actually get an idea about the interval estimation. Okay, and if you are missing out on any of the videos, you can just check the description box below, and you can find the link of the entire playlist. Okay, you can just click on the link and you can have it, and you can go over there and you can find all of my videos that I'll be uploading in sequential order. Okay, and if you like my content, do subscribe to my channel. Okay, so yeah, that is the best you can do. Okay, and I'm glad that if you subscribe to my channel. Okay, so yeah, that does make me happy. And apart from that, I would say that if you have any questions, you can ask me at any time in the comment section below. I'll try my best to resolve those. Okay, I have no issue solving the questions. Okay, in fact I love solving the questions. And apart from that, I would say that yeah, you can also click on the bell icon, so that whenever I'm posting a new video or if I'm coming live, definitely you will get notified. Okay, you don't have to wait for any of the video that I'll be uploading. Okay, you'll just get notified. Yeah, I think this is it for this tutorial. I don't know what I'll be covering, but mostly it is going to be confidence interval construction. Okay, and that one is definitely going to be a lengthy video. Okay, so yeah, just get prepared for that, and you can just refer this one. Okay, you like this video, just like it, share it. You can also comment it, whatever you want. And yeah, so I think I should be winding up right now, and so yeah, so thank you for watching. Goodbye.